Welcome to CW 1.2. Today we're going to talk about parabolas and the various forms we're going to see. So first is standard form. So take a moment and just copy this down into your notes. Standard form is the most common form of any parabola. It's y equals ax squared plus bx plus c. And again, that's just your most common form. That's why it's called standard form. That one should look pretty familiar. The new one is going to be vertex form. Vertex form looks like this. A times quantity x minus h squared plus k. Now this should look new for most of you, and the reason it's called vertex form is you should recall that this point right there, the one I just highlighted in red, that's called the vertex. Think of it as the highest or lowest point of any parabola, and the vertex has the coordinate h, k. And notice how that appears in our vertex form. Here's h, and then here is k. So that's why it's called vertex form. And we really want to get to vertex form as far as graphing goes, because you're going to see why that's a much easier form to work with. So first, let's start with our first equation here. It says graph that equation, find the vertex, axis of symmetry, y int, x int. So first thing I'm going to do is this, find the vertex. Now to do that, we have to have a really nice formula. The vertex formula, now this is what you're going to use to find the vertex of any parabola, not the same as vertex form. Okay, this is actual formula, is negative b over 2a. So that's super important. So I want you guys to box that in your notes and make sure that's very, very clear. Negative b over 2a. So we're going to apply that here. So opposite b here would be positive 6, because that's opposite of negative 6, over 2a. So that'd be 2 times 1. And if you want to write that out, again, you just say negative or opposite of b, which is negative 6. That would then become 6 over 2, which is 3. Okay, now you're probably wondering, so what does that number tell you? That's important to understand. This number is the x value of the vertex. So whenever you do this formula, that will produce the x value of the vertex. So underneath here, we can actually add that. This is the x value of the vertex. Now, of course, if it's asking for the actual vertex, it wouldn't be enough to simply put 3. Right? I can write vertex. If I just put 3, we don't have this y part. So just think, well, how do you find the y part of any formula or any equation if you have the first part, the x? Well, simply just plug in 3. So quickly just plug in 3 to this. Y equals x squared minus 6x. So y should equal 9 minus 18. Y is negative 9. There you go. Plug that in. And there's your vertex. Okay, first part's done. Next is axis of symmetry. So all that means is, if you look at this picture, the axis of symmetry is simply the line that cuts through the vertex like that. And it makes it so that you can fold the parabola perfectly in half. So all you really got to do is take the x value, which in this case is h, and set it equal to x. So for this one, I'll just write axis of symmetry, AOS, is the equation x equals 3. So I just pull that number and I put it right there. Okay, now it says y-intercept and x-intercept. So I'll just do that over here now. For y-intercept, we simply let x equal 0 So y equals 0 squared minus 6 times 0. So y equals 0. There's our y-intercept. Now we're going to find the x-intercept. We're going to let y equals 0. So 0 equals x squared minus 6x. And this should be a pretty standard solve. Just factor out your x. And we have our two answers right there, 0 and 6. So there's our x-intercept. And at this point, notice how this actually is enough to graph it. So I'll just make a line right here for us. I have to use a little bit of this space here. I can make a pretty decent graph now. I know the vertex is 3, -9. So I'll just go 1, 2, 3. Let's say -9 is down here. So there's our vertex. The x-intercept is 0 and positive 6. And let's just connect it for our parabola. And that's a pretty accurate graph. That will be fine. And if you want, we can label that 0, 0 and 6, 0. So at this point, we can see a pretty nice graph that pretty much covers it. I'll even label the vertex, make it a little more clear. This will be 3, -9. And if we want to be fancy, we can actually draw in our axis of symmetry right here. That's x equals 3. So pretty accurate graph here. Now it says determine the domain and range. So I'll just write D for domain, R for range. Remember, domain means how far it goes left and right, all possible x values. I can see it goes on forever, so I'll just write -infinity to infinity. And the range, we can see the lowest point is right here. That's -9, and it goes up forever. So I'll just write bracket -9 to infinity, parentheses. Recall this is interval notation. That should be familiar from your Algebra 2A class. Remember, parentheses mean non-inclusive, and brackets mean inclusive. Okay, part C. State whether the function is increasing or decreasing. So read this graph left to right. I can see this part of the graph is decreasing. So we use the x values for this. I'll put a note. Use your x values. I'll say it's decreasing, so down arrow from -infinity to 3, since I can see it's decreasing in this region here. And then I'll say it's increasing, so I'll do this in green for us. It's increasing from 3 to infinity. And to write the equation in vertex form, this is the cool part. We have the vertex right here, 3, -9. So I can just actually write down what I have already. I have y equals a x minus 3 squared, then -9. Now notice how that's almost complete. The only issue is I don't know this a right there. And what's cool is you actually do know the a. I'm going to use my highlighter here. This a is the same as this a. And a lot of people don't really realize that. So I'm going to make a note for you. Like that. So in your notes, this is like a math secret. That is the same a. So in this, I can see there's a 1 right here, which means this thing is simply a 1. And I can write it or not, it's just a 1. But there's my vertex form. And that's the whole question. A little bit long, but to graph these does take a little bit of time. Okay, now that we've done that, let's do these examples here. Determine the quadratic function. The vertex is 1, -5. The y-intercept is -3. For these, we're going to find that vertex form is super helpful. So I'll put a huge note, use vertex form. I'll write it down for you one more time. And let's just plug it in. Y equals a x minus 1 squared minus 5. And again, the only issue is we don't have this a, but look at this. The y-intercept is -3. That would mean the coordinate is 0, -3. So let's plug it in. -3 is equal to a, 0 minus 1 squared minus 5. And now we just solve that. That would be a minus 5. So a must have been 2. Now plug it back in. So here's our formula. Notice how fast that was. So now that we have vertex form, these questions are much easier. Now the last one, it says determine whether the quadratic function has a max or a minimum value. So in your mind, all you have to do is really picture the parabola. If it looks like this, that has a minimum. If it looks like this, that clearly has a maximum. And we're referring to the vertex point. So that's your highest point, that's your max, and your min is the lowest point. And just think about how that happens. This parabola is considered a positive parabola, meaning a is positive. This is a negative parabola, meaning a is negative. So by simply looking at this equation, I can see that a is positive, which means that for this particular equation, or parabola, it must have a minimum value, since it's a positive parabola. Okay, so I'll circle that. But now it says actually find, right here. It says find the minimum or maximum value. So to do that, we're going to use the vertex formula. So that's simply -b over 2a. So I'll plug it in. That's 4 over 2, which is 2. Recall that this is your x value of the vertex. And all you got to do is find the y value. So 2 comma, plug in 2 right there. So that would be f of 2 is equal to 2 squared minus 4 times 2 minus 5. That's 4 minus 8 minus 5, which is -9. So the vertex is 2, -9. Now all you got to do to find the actual value, when it's saying to find the value, that is referring to the y value. So just take this number right here, and that is your minimum. And that's it.